Hello. In this video, we are going to talk through finding the interquartile range. So the measure of variability that we refer to as the interquartile range. In order to do that, we're also going to need to refresh our idea of finding the median of a set of data, because we need the median in order to find the interquartile range. The interquartile range is based on dividing a set of data into quartiles. So if we had a set of data and we divided it into 4 quarters, once it's in ascending order, the interquartile range represents the spread of the middle 50% of the data. So it's sometimes referred to as the mid-spread, but I'm going to refer to it as the interquartile range. Lots of people prefer the interquartile range rather than the range of the data as a measure of spread because it only focuses on the middle 50%. So some people could say that that is the most important section of the data, the middle 50% of the data. So the interquartile range is a measure of spread, and it is sometimes preferred to the range of the data because it's focusing on the middle 50%, not the full 100% of the data. We're going to talk through some examples and look at how to find the interquartile range. In order to get there, we need to first find the median. Then we need to also find the lower quartile and the upper quartile. During this video, I'm going to refer to those as Q1, Q2, and Q3. Q1 being the lower quartile, Q2 being the median, so that is the middle of the data, and Q3 being the upper quartile. Okay, let's work through an example. So here I've got a list of data. I've got a data set here, and I'm being asked to find the interquartile range. Before I can find the interquartile range, I first need to find the median of the data set. So what I'm going to do is I'm going to take all of these bits of data and I'm going to write them in ascending order. I'm going to put them in order from smallest to biggest. Once the data is in order from smallest to biggest, then I can select the median by finding the middle value. So we could do that by crossing off our lowest values and our highest values until we get to the center, to the middle value. So in this data set, the median is 7. So next I'm going to try and find the lower quartile. So I'm just going to focus on these 6 bits of data to the left-hand side of the median. So I'm going to focus on 1, 2, 5, 5, 5, and 6. And I'm going to use the same method that I used to find the median in order to find the lower quartile. So if I was looking for the middle of this data set, there's 1, 2, 3, 4, 5, 6 numbers in this data set, an even amount. So I would be expecting to find 2 numbers in the center. So I could have crossed off my 2 lowest, crossed off my 2 biggest, and been left with these 2 values. But the lower quartile cannot be 2 values. What I need to do is find the middle point, the mid value between 5 and 5. When the numbers are the same, my lower quartile would simply be 5. If it's a bit tricky to work out your middle value at this point, when you're left with 2, you could add them together and divide by 2. So in this case, 5 add 5 would be 10, divided by 2 would be 5. Now I'm going to work out the upper quartile. So this time I'm going to look at the numbers to the right-hand side of the median. So I'm dealing with 10, 11, 12, 14, 16, and 19. And again, I'm going to find the middle value. Because there's an even number in the data set, I end up with 2 numbers again. So in order to work out my upper quartile, I'm going to add 12 and 14 together to get 26. Then I'm going to divide by 2 to get an upper quartile of 13. Again, we can see that the midpoint between 12 and 14 would, of course, be 13. So let's have a little look at what I found so far. So the first thing I did was I found the median, and it was the middle value once the data was in ascending order, and the median Q2 was 7. I then went to find Q1, the lower quartile. So I focused on the numbers to the left-hand side of the median, and I used the same method to find the lower quartile. Because I was left with two numbers, I had to work out the midpoint of the two numbers, or I had to add them together and divide by 2. So that gave me Q1, the lower quartile, being 5. I did the same for the upper quartile. I focused on these 6 numbers. I found the midpoint, and then I'm looking between 12 and 14. That gave me Q3, the upper quartile, being 13. So this is all my method. Now I can go ahead and state what the interquartile range is. To find the interquartile range, I take my upper quartile and I subtract my lower quartile. So I take my upper quartile, subtract my lower quartile, and that gives me the interquartile range. So in this question, the interquartile range is 8. The middle 50% of the data is spread over 8 data points. We're going from 5. So then I can go ahead and work out the interquartile range. To find the interquartile range, I take Q3 and I subtract Q1. That's going to give me the spread of the middle 50% of the data. So to find the interquartile range, I take my upper quartile, I subtract the lower quartile, and I find my interquartile range, which in this question would be 8. I'm going to talk through a second example of finding the interquartile range. You do, of course, have the ability to pause the video if you'd like to go ahead and have a go at this question yourself. Okay, so I've got another data set, and I'm asked to find the interquartile range. First thing I'm going to do is I'm going to find the median. So I'm going to place the data set in ascending order from smallest to biggest, and then I'm going to find the middle value, the median. So now I've rewrote my data in order from smallest to biggest, and I found the middle value. So my median, Q2, from this data set is 5. And we can see that because I've got 5 bits of data before the median and 5 bits of data after the median. Because I have a true middle number here, that means that I ignore it from working out the lower quartile and also from working out the upper quartile. So to work out the lower quartile, I'm just going to focus on these 5 bits of data, -1, 0, 1, 4, and 4. And using the same method that I used to find the median, I'm going to find Q1. So this would be my lower quartile. And again, you can see why, because there's 2 data points in front of the lower quartile and 2 data points after the lower quartile. So Q1, the lower quartile, is 1. Now I'm going to focus on these 5 data points. And again, I'm going to find the middle value of these 5 data points. My upper quartile, Q3, would be 15. And again, you can see why. 2 data points after and 2 data points before. So 15 is the middle value of these 5 data points. So what we have so far is this. We've worked out that the median, Q2, is 5. We put the data in order and we found the middle value. So the median is 5. Because we have a true middle number, one middle number, then we ignore that from the next step in our method. So we're just focusing on these 5 values. We find the middle of these 5 values. So my lower quartile, Q1, is 1. Then I look at my top 5 values and find the middle number. So again, this would be Q3, my upper quartile. So in order to find the interquartile range, I'm going to take my upper quartile and subtract my lower quartile to give me the spread, the interquartile range that I'm aiming for. So the interquartile range of this set of data is 14. 15, take away 1, Q3, subtracting Q1 is going to give me 14. Okay, another example for me to talk through. Again, if you want to go ahead with the question, pause the video at this point and have a go at the question yourself. Got another set of data. This time when I look at the data, you'll notice that there's an even number of data points in this data set. 1, 2, 3, 4, 5, 6, and another 6. We've got 12 bits of data. Because of that, when I put them in ascending order and find the median, I'm going to find myself with 2 numbers in the center of the data. So if I place this data set in ascending order, it now looks like this. But if I want to go ahead and find the median, I need to look at these 2 numbers. Because I had an even amount of data in the data set, I'm left with these 2 numbers in the center. So the median of this data set actually lies here, in the middle of 10 and 12. So my median is going to be 11. Another way of finding that is adding these 2 numbers together, 10 add 12 is 22, and dividing by 2 to get 11. So my median, my Q2, is 11. But this now slightly changes our method for finding Q1 and Q3. Because I didn't find a true middle number, this 10 is going to be included in this data set to the left-hand side when I go to find Q1. And this 12 is going to be included in this data set when I work out Q3. So now I'm going to look at these 6 bits of data, minus 14, minus 2, 0, 0, 1, and 10. And I'm going to go ahead and find the middle value. When I find the middle value, again, I'm left with 2 bits of data, 0 and 0, the midpoint of which would be 0. So Q1, my lower quartile of this data set, would be 0. Then I'm going to look at these 6 data points and find the middle value. Again, I'm going to be left with 2 numbers, because you can see I've got 12 and 16 to this side, and 18 and 25 to this side. So I'm left with 17 and 18, which means Q3, my upper quartile, is going to be 17.5. If I added both of these numbers together, 17 add 18, I get 35. Divide by 2, that's going to leave me with 17.5. So what I have so far looks like this. I worked out my median, Q2, as being 11. It's where this red dotted line is. The median is 11. Because I had an even number of data, I expected 2 data points in the center, and I found the middle value. I found the average of those 2 data points, which was 11. Then I went ahead and found Q1, looking at these 6 bits of data, and Q1 was 0. And then I went ahead and used these 6 bits of data to find the upper quartile. The middle value between 17 and 18 was 17.5. Remember that when our median is not a true value, then we include this number in this data set, finding Q3, and we include this number in this data set, finding Q1. Now I found Q1, 2, and 3, I can go ahead and find my interquartile range by doing a little subtract. 17.5 take away 0 is 17.5. So Q3 subtract Q1 gives me an interquartile range of 17.5. So now it's your turn to have a go at a few questions. On the screen, I've put 3 separate data sets. For each of the 3 data sets, I'd like you to find the median, followed by the lower quartile, followed by the upper quartile, and then use those answers to find the interquartile range. So very similar to what I've done in my examples on the previous slides. Could you show me your full working out, your full method, your full notation of how you went and found the interquartile range? Could you have a go at each question? Could you pause the video now, please? Okay, welcome back. I'll just talk you through a few of my solutions. So my first answer looks like this. So I took the data set, I wrote it in order from smallest to biggest. I found my middle number, which was my median of 5. Then I looked at the data to the left-hand side of the 5 and found the middle value there, which was my Q1, my lower quartile being 2. Then I looked at the data to the right-hand side of my median and found the middle value of 10, which was my upper quartile Q3. 10 subtract 2 gives me an interquartile range of 8. There was no points during this question where we ended up with 2 bits of data as either our median or upper or lower quartiles. This is what your method and notation should look like. That's how you're going to get full marks in your exams or tests. Question 2, I'm going to present it in a very similar way. So I've wrote my data set in order from smallest to biggest. I found my middle value, my median being 8. Then when I've looked at the data to the left-hand side, this time I am left with 2 values, -1 and 5. So I find the halfway point, I find the average of -1 and 5 to give me my lower quartile of 2. To the right-hand side of the median, I also left with 2 bits of data in the center, 10 and 19. I add them together to get 29, divide by 2 to get Q3, my upper quartile of 14.5. Then I take 14.5, subtract 2 to give me an interquartile range of 12.5. So the median was a true middle value. So that was itself separated from the next step, working out lower quartile and upper quartile. The third question, I'm going to present it in a very similar way. So I've took my data, wrote it out in order from smallest to biggest. Because there's an even number of data, I was expecting 2 values in my center when I go to select my median. Those 2 values are 0 and 2, so the halfway point of 0 and 2 is 1. So my Q2 median value is 1. Because this is not a true middle value, this 0 is now included in this data set. So I go ahead and find the middle value. My Q1 lower quartile is 0. And this 2 here is also included in this data set when I go ahead and try and find my Q3, my upper quartile, which ends up being 4. Then I go to find my interquartile range. Q3 subtract Q1, 4 take away 0 gives me an interquartile range of 4. Very well done if you were able to answer all 3 questions correctly. Last task for you to have a go at. On the screen, I've put on the left-hand side of the screen 5 data sets. On the right-hand side of the screen, there is 5 interquartile ranges. For each data set, I'd like you to work out, showing me full working out, how you found the interquartile range and match up the data set with the correct interquartile range. There is one data set that does not match up, and I'd like you to highlight that as the odd one out. Okay, could you pause the video at this point and have a go at matching the data sets to the interquartile range? Okay, welcome back. I'll just show you my matchings. They should look something like that. So the bottom data set is the odd one out. It does not match up to the 10, which is also the odd one out. The correct interquartile range for this data set would have been 5.5. You can see where the other four match up correctly. Just take a little bit of time to mark and assess the work you've had a go at. If you were able to match up these four data sets and also highlight the odd one out, then that is very good. You've shown a great understanding of finding the interquartile range. Well done.